In this video, I want to have a look at surds and irrational numbers. So I want to look at what they are. So the first thing we've got here is sort of a number family tree. So we start off at the top with real numbers. So every number, every type of number that you have ever seen is a real number. Then it splits into two categories with either got rational numbers or irrational numbers. So the difference there is that rational numbers can always be written as a fraction and irrational numbers cannot be written as a fraction. So our rational numbers then split into integers, which are our whole numbers, and every other sort of fraction. So either whole numbers or fractions. But what we're interested in is this branch. So again, irrational numbers are anything that can't be written as a fraction. Then we've got something called transcendental numbers, and they're numbers that we can't write down exactly. So things like pi. So we know the value of pi is approximately 3.14, and the decimal will go on forever with no pattern. And we can find pi accurate to millions and millions of decimal places, but we can't write down its exact value. Another example of it is e, which is another number. The main one we're interested in this video though is surds. So a surd is a square root or any other sort of root, so it could be a cubed root for example, whose exact value cannot be found. So for example, we could have the square root of 2 or maybe the cubed root of 10. So we can represent these numbers, not like we can't represent pi with numbers, but we can represent surds. We just can't write down their exact value because as a decimal, its digits will go on forever without repeating. So let's have a look at an example. We're asked which of the numbers below are surds. So to help you figure this out, you can put these into your calculator. If you type in the square root of 100, it's going to give you exactly 10. So because we can find the exact value of the square root of 100, it is not a surd. So I'm going to put a cross above it there. So even though it's got that square root sign in it, because we can find its exact value, then it's not a surd. Whereas if we put the square root of 10 in our calculator, it's going to give you a decimal. So the square root of 10, and that decimal goes on forever. So the square root of 10 is a surd. The square root of 36, if you pop that in your calculator, will give you 6, so it's not a surd. The square root of 52 will just give you a decimal that goes on forever, so it is a surd. And the square root of 144 would give you 12, so it's not a surd. Which of these numbers is irrational? So remember, rational numbers can be written as a fraction, irrational numbers can't. So if we have a look at this first one, that 4 1/3, we know that we can rewrite that into an improper fraction, which would be equivalent to, if you do 4 times 3, that's 12, plus the 1, we'd have 13 over 3. So that means that is a rational number because we can write it as one fraction. So it's not irrational. Now if you put the cubed root of 8 in your calculator, that's going to give you 2. Now 2 is a whole number. It can be written as 2 over 1. So that means it's a rational number, so it's not irrational. Now 2 pi, we know that pi goes on forever and pi is an irrational number. If we double it, it's still going to be an irrational number. And if you type 2 pi into your calculator, you'll get a decimal. And if you try and hit that SD button on your calculator that converts from fractions to decimals, it won't do it because it can't. So 2 pi is irrational. 0.275, we could write that as a fraction as 275 over 1,000. And we could simplify that fraction, but the fact that it can be written as a fraction at all means it is a rational number, not irrational. And our last one is the square root of 7. If you put that in your calculator, because it's a surd, it's going to come out like these ones did up here, and it's going to give you an ongoing decimal. So this one is an irrational number as well. So that's having a look at surds and irrational numbers.